everyone. In this video we will discuss about the basic operation of matrices. As we know that matrix is nothing but an arrangement of numbers in the form of rows and column. So suppose if I say A is a matrix, m by n matrix. So what is it? It is just arrangement of the numbers, say A11, A12, these numbers A1n, similarly A21, A22, A2n and so on, AM1, AM2, so on, AMN. It is an arrangement of these numbers A11 to AMN in the form of rows and columns. So these are the rows. This is row number 1, this is row 2 and so on. This is row m. So how do we know that always the first number represent the number of rows and the second number represent the number of columns. Okay, so here we have n columns. So this is column 1, this is column 2 and so on. This is column n. Okay, so matrix is nothing but the arrangement of the numbers in the form of rows and columns. Okay, so this m and n are called the dimension of the matrix. Like suppose if A is a matrix of order 2 by 2, we say that it will be a matrix like this: A11, A12, A13, A21 and A22. So what does actually this A11? Why I am writing this A11? It means this element A11. This is the element in the first row and first column. So that's why both subscripts are 1, 1. Similarly, this element, this is in the first row but the column is second. Okay, and this is how it works. So we say that A is a matrix of order 2 by 2. We call it as order 2 by 2. Or since here both the number of rows and columns are same, so we say that it is a matrix of order 2. So for all those matrices where the number of rows and columns are same, we call such matrices are square matrices. It is a square matrix. So we say that A is a square matrix of order 2. Similarly, if A is a matrix of order 3 by 3, we say that A is a square matrix of order 3 and so on. Moving on to the matrix addition and subtraction. So first of all, we should know that what is the condition when we can add or subtract two matrices. Okay, so what does this mean? That we cannot add any two matrices in general, but we do have a condition. So what is that condition? If A is a matrix of order m by n and B is a matrix of order p by q, then it is possible to add or subtract them if and only if the number of rows in the first matrix should equal to the number of rows in the second matrix. That is, m should equal to p, and the second condition is that number of columns in one matrix should equal to the number of columns in the second matrix. Because if that condition doesn't true, it's not possible to add or subtract them. Okay, because this is the basic condition. So if one of the condition is not fulfilling, we cannot add them. So for example, if A is a matrix of order 2 by 3 and B is a matrix of order 2 by 3 again, then it is possible to find A plus B and A minus B. This is possible. Okay, so when we add or subtract two matrices, it will again give you a matrix. So it should have a dimension. So in this case, as it is possible to add two matrices because their dimension is same, the resulting matrix, the A plus B and A minus B, this will be matrices of dimension same as the dimension of A and B. Okay, so the dimension will be 2 by 3. So if I add A and B matrices which are of same dimension, we will get the same matrix of the same dimension. Okay. On the other hand, if A is a matrix of order 2 by 3 and B is a matrix of order 2 by 2, here number of rows are same, okay, in both the matrices, but the number of columns is not same. So in this case, A plus B and A minus B is not possible, as their dimension is different. Okay, the number of columns in one matrix is not same as the number of rows in the second matrix. Okay, now let's come to the calculation. How do we add two matrices? So let us consider A is the matrix. This is an example. A is a matrix, say let us take any number 2, 3, 4, 1, 0, minus 1, and we have matrix B as say 7, minus 1, 2, 0, 1, 1. Okay, now, so first of all we should check whether it is possible to add two matrices or not. So this is a 2 by 3 matrix because it is having 2 rows and 3 columns. Similarly, B is also 2 by 3 matrix. So it is possible to add them. So what I said, when you add them, you will get a matrix of the same dimension. So it will be again a matrix of order 2 by 3. So it will be having 3 columns and 2 rows. Right? So we will be looking for the digits over here. Now, how do we do that? When we need element here, it will be the addition of the element at the same place, as we are finding plus. So what we will do, we take the element from each position. 2, in between the sign is plus 7. We will do element wise addition. Similarly for here, 3 plus the element is minus 1. Then 4 plus 2. Similarly here, when we are working with this 1 with 0, okay, it's quite simple. You just need to pick the elements at the same position, okay, and add them. What is the reason we are adding them? Because here we have plus, so that's why we have put the sign plus in between. Okay, so after that, what is left? Just simplify that and you will get your result. So what will be the result? You just do the addition. 2 plus 7, 9. 1 plus 0, 1. 3 plus minus become minus 1 is 2. 0 plus 1 is 1. 4 plus 2, 6. Minus 1 plus 1 gives you 0. So this is the addition of two matrices A and B. Okay. Now, moving on to the next. If I want to find A minus B. So what do you think what it will be? Again, it will be a matrix of the same dimension, 2 by 3. Okay. So it means we are looking for the 2 rows and 3 columns. So you can see that what is the difference between these two? Here the sign is plus, here the sign is minus. So we will again do this element wise subtraction. Okay, so what it will be? 2. In place of plus, now we will put the sign minus. Okay, here again 1 minus 0. 3 minus of minus 1. 0 minus 1. 4 minus 2. Minus 1 minus of minus 1. So what we have done, we just changed the sign. It was plus in the previous one, now here it is minus. Now just simplify the result. So it is A minus B. 2 minus 7 gives you minus 5. 1 minus 0 gives you 1. 3 minus minus, this minus minus become plus. So 3 plus 1, 4. 0 minus 1 is minus 1. 4 minus 2 is 2. Minus minus become plus. So this will again become 0. Sorry, I have made a mistake here. It is actually 1 here, so it is minus 1. By mistake I mentioned minus 1. So here also the number change, it's not 0. So minus 1, it become minus 2. So this is the resulting matrix 2 by 3, A minus B. Okay, clear? Now you can see one thing. This is the property of the matrix. What is the property? Here we obtain A plus B. What will happen if I find B plus A? Again, we have to check the dimension of both the matrix. Both are same. So yes, it is possible to find them. It will be again a matrix of order 2 by 3. What do you think will be the difference? So what is the difference here? The position of A and B. In this one, A is positioned first and then B. Here the position is changed. B comes first and then A. So the procedure remains same, but we just change the position of the elements. So here we started, when we were finding A plus B, we kept the element of A at the first position and then the element of B. Okay, here we are doing B plus A. So we start with the element of B first. So 7 plus 2, the element of matrix A. Similarly, minus 1 plus 3. 2 plus 4. So just the position change. So 0 plus 1. 1 plus 0. And this gives you 1 plus of minus 1. Now, we know that matrix addition is commutative. Like it doesn't matter you write 7 plus 2 or 2 plus 7. It will be same. Gives you 9, 1, 2, 1, 6, 0. It is 2 by 3. So from these two results, what you can see, this matrix A plus B and B plus A, both are same. The numbers are same. So this says the property that matrix addition, instead of writing A plus B, I will simply write the property as matrix addition is commutative. Commutative. So what does it mean? If you write A plus B or B plus A, it doesn't matter. It is same. So this is commutative property. So let us check what will happen to this property in the case of subtraction. We already obtained A minus B. Let us see what will be B minus A. So again, as we did for addition, we will pick the element of B first and then the element of A. So element of B is 7 minus the element of A, which is 2. Similarly, minus 1 minus 3. 2 minus 4. 0 minus 1. 1 minus 0. 1 minus of minus 1. Okay, so this gives you 7 minus 2 gives you 5. This gives you minus 1. Minus 4, 1, minus 2 and 2. So this is your matrix B minus A. So if you look at carefully at these two matrices A minus B and B minus A, here the number is minus 5. Here you have plus 5. Here you have plus 4, you have minus 4. Okay, and so on. So what you observe here, the sign, there is a change in the sign of A plus B and A minus B and B minus A. So in this case, A minus B is not equal to B minus A. Instead, we have A minus B is equal to negative of B minus A, which is true even for two real numbers. Like if you have 2 minus 3, this gives you minus 1. On the other hand, if you do 3 minus 2, you will get 1. So the same property holds for this. So in this case, we see that matrix subtraction is not commutative. Okay, so here the property become matrix subtraction is not commutative. Okay, I hope it's clear.